Hello, welcome. My name's Phil Winder, and I'm the CEO of Winder AI. As an AI consultancy, we're working with a number of clients to incorporate private knowledge into LLMs. One of the key questions in those projects is what's the most effective way of giving the LLM the domain specific knowledge required to do its job effectively? So, in this talk, I'm going to attempt to demystify the differences between fine tuning and RAG. To do this, I'll spend a little bit of time explaining how LLMs learn and why RAG represents another opportunity to do the same thing. Question answering on private data is the top use case for LLMs, so I'll be focusing on this. So the first half of the presentation is more for beginners. The second half gets more technical. I'll present a recommendation of for when you should use RAG and when you should use fine tuning towards the end. To reduce the scope of this presentation, I won't be talking about implementation details, nor will I be talking about the architectures involved. RAG in particular benefits from a significant architectural flexibility, which has led to a wide range of different implementations. I've scheduled to do another webinar in the future about this. Please ask your questions in the chat functionality of the platform that you're using, and I will answer them at the end. Okay. So hopefully we can all see this. Split into 4 sections, and the first section I'm going to delve into is a little bit introductory, but I think it is useful to cover the basics so everyone's on the same page, and it helps to explain some of the things that we'll find later on. Okay, so let's see if I can remove my face a little bit from this. That one. There we go. So one of the things that we need to ask is, what is an LLM? And an LLM provides you with lots of fuzzy language. So yeah, actually, sorry, let me break it down. Large language models, which are known as LLMs, provide you with a model that is very good at predicting the next word on average. Contained within those words is knowledge. And I'll leave it to the philosophers in the room to define the word knowledge. But as an example, LLMs tend to be quite fuzzy and therefore they struggle with logic. The reason for this is that the training data that these models are trained upon consist of all sorts of contradictions. Any LLM should really know that 1 + 1 is 2. It's a basic test that all LLMs kind of have to pass. But here is an example that I found from a Black Eyed Peas song that clearly tells the LLM that 1 + 1 might not be 2. It could be 3. It could be 4. It could be things that are not even numbers. And it could even be a swear word at the end there. This is a very small example of what the training data really looks like. Remember that the LLMs are machine learning models trained in a supervised manner. I have other videos on the Winder AI website if you're interested in learning more about that. The goal of this model is to predict the next word. So obviously the result of that is going to be fuzzy, but LLMs compress a lot of text and about a lot of different topics. So it makes them particularly useful as knowledge bases. Internalized knowledge is the primary use case for LLMs, but it turns out that they're also really good at representing style and infusing concepts into the writing. That'll be important for when we look at what fine-tuning is good for a bit later. Finally, LLMs are typically imbued with a certain set of aligning principles from the authors. Some attempt to apply ethics or rules, or some attempt to make the LLM more useful for particular tasks. Either way, this could be considered a form of style. Okay, I'm just gonna double check whether there's any issues. Nope, all looks good. What do they not provide? LLMs do not provide the following. They don't incorporate live data. So, for example, they can't tell you when the next train arrives, or if you're in the UK, if it'll ever arrive. They don't provide problem-specific information. For example, they don't know how to double check that you have a passport when you want to book a flight. They don't contain domain-specific terms even. For example, it doesn't know what your product is, unless you're Microsoft or somebody. And finally, the big one, they don't contain any private or proprietary data. Supposedly, anyway. That's what OpenAI says. Whether they take that data and use it, we don't know. For example, it doesn't know about your company handbook. So the question is, how do we get that information into the LLM? So, I was inspired by a Reddit post the other day, which talked about LLMs as idiots. You should treat them as idiots and just assume they're going to do something idiotic. So please meet these two idiots in the best fancy dress you've ever seen. Imagine that your company has sold some technology and a customer has called the technical support line. So idiot one is a reasonable LLM. Think of a GPT type model. Idiot 2 is a fancy database with the company manual installed, something like a search engine, Google search or something over your company documentation. And the customer comes in and asks a question. I placed my router in the microwave. Is the internet broken? Okay, innocuous question, quite a reasonable question. So idiot number one, they come back, he comes back and he realizes he's got quite a lot of general knowledge. I've got some pretty good general knowledge. I've learned a lot of things from all over the internet. I recall that microwaves and Wi-Fi use similar parts of the electromagnetic spectrum. That microwaves have Faraday cages in them to stop humans from melting themselves. And I know that the internet is one large distributed network. So my answer is going to be the internet is a distributed network. The Faraday cage is blocking millimeter radio waves. Okay. Factually true, not particularly helpful. Idiot number two, the one that uses the search engine, well, they think, let me search the manual. And so they search the manual for some of these keywords, and the word place or placement is in there. So they must be talking about placement. Imagine that ranking the highest in the search engine. So they're going to return the words for that segment of the manual. So the answer here is place the router in an unobstructed position away from walls, which is contained within every router manual everywhere. Nothing to do with microwaves, nothing to do with the internet. So what's the point? Well, the point is that neither of these idiots really answered the question. So idiot one provided some of the facts, and indeed it is unlikely that the user broke the internet, but from the perspective of the user, the internet is not working. It is broken. Idiot 2 almost gets there by suggesting a better placement of the router, but it doesn't mention anything about microwaves because they aren't mentioned in the manual. So the true answer is probably some combination of those two. The internet is not broken, but it's not working for you because you've placed the microwave and you've placed the router in the microwave. So take it out. Incidentally, I asked GPT 3.5 this question, and it gave me a reasonable answer, but it had some hugely sarcastic undertones. Placing your router in the microwave can indeed disrupt your internet connection. Or if you accidentally placed your router in the microwave, lots of I feel like that ChatGPT should sort of append lots of sarcasm warnings at the end of all of its messages. Okay, so let's talk a little bit more about knowledge and how we try and get that knowledge into our LLMs. So what does fine-tuning do first? Well, fine-tuning is the process of attempting to nudge the weights of a large language model to map new points in high-dimensional space. A bit of a long-winded, complicated sentence there. I'll try and explain that a bit better with a few pictures shortly. Fine-tuning, as it's normally done, is indiscriminate. Different parts of the LLM represent different concepts. So think of the LLM as like a giant stack, a giant sandwich of these weights that can be trained different ideas, different concepts, different meanings. Fine-tuning affects all of them all at the same time. And even if you're talking about LoRa or an adapter-like method, or if you're just fine-tuning on the raw weights, effectively you're changing all of them all at the same time. And that affects everything. It affects everything. It affects everything within the LLM. It affects the concepts that the LLM understands. Things like the cadence, the humor, the meaning of words, the ethics, the goals, and yes, the knowledge. So this is the biggest, what I perceive is the biggest issue with fine-tuning right now. And all of the current research attempts to find better ways of nudging those weights to optimize for a measure of performance that isn't necessarily directly useful in an industrial context. I don't particularly care if a new training method adds 1% accuracy to the LLM, if it starts talking like Bugs Bunny or something like that. I only care if it's, or if I care about adding domain-specific knowledge, I also don't want it to lose all of the other behavior it already has and all of the other knowledge. So this is a fundamental limitation of the current architecture of LLMs, the way that the spreading, the way that there's no understanding of the concepts that are spread throughout the LLM. And it would have to change quite significantly to tackle those issues. So what does RAG do? So first, RAG stands for Retrieval Augmented Generation. In its simplest form, RAG retrieves data from an external data source and passes it to the input of the LLM. If the answer is in the context, the LLM can give that answer to the user. If the answer is not in the context, then it can't. Or even worse, it guesses. So this makes it clear that the most crucial aspect of RAG is that you must retrieve the answer for the answer to be answerable. Sounds silly, but it basically removes the burden of the retrieval. It removes the retrieval burden from the LLM and places it on this external mechanism. So you have this hugely powerful blob of knowledge, but you basically end up ignoring all of that knowledge and just using it like a translator, except that the LLM is more trying to explain what it's being given in the context rather than translate. So it's more of an explainer than a translator. But remember that that most LLMs have not been fine-tuned to be explainers, not explicitly anyway. That's not their training data. So that's another big area of potential research. So in summary, LLMs bring fuzzy knowledge, RAG brings live data. Which brings me to the big myth standing in the room. So if you Google this on the internet, you'll probably find something saying that fine-tuning can't add knowledge. So firstly, how do you think that LLMs got their knowledge in the first place? Like, yeah, that's right. They got their original knowledge by training, by tuning, by fine-tuning, effectively. And it also brings up the awkward conversation again of what is knowledge. So the problem is that when people talk about fine-tuning and knowledge, they're not really thinking about how the training affects the underlying model. They're usually talking from the perspective of an individual use case. And typically that use case is question answering. So we could probably rewrite that myth as, for the purposes of question answering, fine-tuning doesn't work well. But that's not entirely true either, because I can demonstrate that question answering does work well in a dummy fine tune. So this is just a quick sort of thought experiment. Well, it's a practical experiment that I've done, but it's a bit of a toy experiment to sort of prove to you that you can force LLMs to learn stuff. So again, let's go back to the example of being a professional customer service representative. And what we're going to do is try and compare fine-tuning with RAG. So here's the RAG example. I'm literally going to give the answer to my question in the context window of the LLM. Okay, so you can see it here. I've placed the router in the microwave, and the answer is no, the internet's not broken, blah, 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 blah. And then we're at the end, we're asking it again, now answer the following question. It's exactly the same question. Okay, again, I fed this into ChatGPT. And you'll see almost used the answer that I provided in the context, but it still couldn't quite stop itself from making the answer a little bit nicer. So this is an example for fine-tuning. So what we're going to do here is we're going to build some question-answer pairs, or QA pairs for short, and we're going to feed that into our fine-tuning mechanism. And we've been working on a project called Helix, which helps makes it easy to perform fine tunes on LLMs. So we've got a prompt here from a notional human, and we've got the answer that we want the bot to provide. This is the QA pair. You'll see it's the same question answer pair that we had last time. So I fed that into Helix and fine-tuned a new model based upon Mistral 7B, and I gave it the answer and told it to answer with it verbatim. And you can see in the output, the bottom left there, that the fine-tuned LLM model has given me the exact output that I wanted. So, in that sense, I have given it knowledge. I've imbued it with domain-specific knowledge that did not exist previously. The key here is precisely how we did it and the fact that we gave it some real-life examples to actually learn from. If you want to try this out yourself, please visit tryhelix.ai and sign up and give it a whirl. And then, do let me know if you've got any questions about that. So this was So what was the point of that? Well, that was a demonstration of RAG answering the question using the context. The only requirement is that the LLM is smart enough to use that context. And since all LLMs have been trained to use context to predict an answer, nearly any LLM will work. The fine-tuning example here has been performed to maximize overfitting in this case. So this almost makes it look like a lookup table. When it's given a question, it spits out that exact answer that we're expecting. And typically, this is not something you would want to do, but it's a good example of how you're shifting the weights in the model to give you the answer it wants. The point is that you can't claim that fine-tuning doesn't add knowledge. It does. If the QA pairs matches your definition of adding knowledge, then I've just shown that you can do it. But the real question is, for the purposes of question answering, which is better? And of course, it depends. It depends. It always depends. Everything depends. This is engineering. It wouldn't be engineering if it didn't depend. So, of course, a fine-tuned model might understand the domain better. It might understand technical terms better. It might use more precise language. It might communicate in a style that is better suited to your domain. It might be lower latency because you don't need as much context. It might be lower latency because you don't need to call an external system. And you can even train the model on actual QA pairs, then it might even be able to answer a question. Okay, so there's lots of potential benefits there. But let's just pause there. And I'm going to try and get that idea of overfitting sort of burned into your mind. So picture the actual manifold of the high dimensional language model in your mind's eye. It looks, we don't know what it looks like, but it looks something like a sea with lots of waves in it, except those waves are all rotated and wrapped around themselves and they crisscross and, horrifically complex. Each point in that space represents a prediction for the next word given the previous words. So, picture yourself in that and you're sort of moving around that space and picking out the next word, and you sort of generate a trajectory through that space. Okay. When we fine tune, we're altering the position of those waves. And if you overfit, like we did in the previous example, you're adding a spike out of those waves at exactly where your question is. So if you ask that exact question, then you land perfectly on that spike and you get the right answer. And it's a series of spikes rather than just one. But anyway, doesn't matter. If your question is different by one keyword, or if it's different entirely, then you're going to screech to the left, and you're back in the sea of the underlying LLM, which probably can't answer your question and will come up with another answer. So generally, you don't want to do this. You don't want to overfit because it's unlikely that you're going to see that exact question in real life. You want it to generalize over different phraseology. So the key is training the LLM on representative and diverse user queries. You can't just feed in a document and say, answer this question, because you'll never land on that spike. So what I'm saying here, and just like the rest of machine learning, if your training data does not represent the production queries you're trying to serve, you won't get good results. It's the same old adage. It's garbage in, garbage out. If you truly want to fine tune your LLM, you need to come up with a training data set that contains as many possible question answer pairs that your LLM might face. Oh, and if you had all of them, then obviously you'd get 100% accuracy, but that's impossible too. So you're just trying to do the best you can there. Okay. So let's get into the meat of the discussion now. So hopefully, I hope you're getting an intuitive feel for how fine tuning works. But let's get back to the topic of conversation and talk about the performance differences over more representative data. So if you go on the internet and start doing your research, and I'm going to have to just quickly remove my face again so you can see the full screen. Where are you? There you go. If you go on the internet and start doing your research, you'll come across lots of papers doing this exact comparison. So what I've tried to do is to do that for you and summarize the results. Well, maybe not many. Some papers are doing precisely what I've just said. They are feeding in full raw documents and then using the LLM to ask questions of it. And unsurprisingly, they found that fine-tuned performance is rubbish, as you'd expect, because they're fine-tuning, they're training the model to predict something that is never going to exist. It's never ever seen a question before. It's never seen an answer before. So like how do you expect it to how do you expect it to actually give you a decent answer? They're fine tuning on raw text data. Yeah, so if you, for example, passed in a query that matched some of the raw text, it would probably be able to predict the next word in that document quite well, but it can't give you answers. So obviously, the fine tuning results are horrible. And some of these papers actually suggest that the performance is worse than the base model because obviously you're also detuning some of the base model. You're trashing some of the performance of the base model. So yeah. However, if you sort of dig through that, you do find some better papers. And a better example is this paper that attempted to generate question answer pairs based upon raw data. And they demonstrated that you do get better performance with fine tuning. However, RAG still produces overwhelmingly better results in their experiments. You have to be a little bit careful when you're reading the numbers in all of these studies. And I'm not going to dig into them too much because they all use slightly different metrics and they have different ways of representing those metrics. But you can compare the results within a paper. And here you can sort of generally see, I'm going to have to start explaining. You can start to see that RAG is orders of magnitude better than fine tuning alone. So yeah, in this case, we've got a comparison where the plus and minuses mean none of that thing and adding that thing. So minus RAG is no RAG and plus RAG is with RAG. And then they've got the fine tuning down the left hand side there. So that tells you whether they included in fact, yeah, no, let's not go through it. Just take my word for it. They found that RAG was significantly better than fine tuning. Okay, but there's a few other interesting results that come from this paper, and one of them you can sort of just about see here. The small model at the top tends to show surprisingly poor performance when just using RAG. So that's that 26.13 in sort of the middle of the top there. They demonstrated that fine-tuning plus RAG approaches the performance of some of the larger models. You've got the 49 sort of 50 at the bottom right hand side there. So that's fine tuning with RAG. And that's sort of approach, it's not as high, but it's approaching some of the scores, the 58 and the 63 for just RAG alone. So I think this is quite an interesting result, because I think that's indicating that using a small model plus fine tuning plus RAG can approach the performance of a larger models. So if you're trying to optimize for performance or for resources, for example, that might be a very useful finding. But in general, here we go. This is the recommendations. RAG tends to be better when you need fast data loading. One of the big problems with LLMs at the moment is that the fine tuning takes a long time. If your data updates often as well, for a similar reason, it's quite hard to update an LLM. It's very easy to update a RAG solution. If your data is non-text, obvious issues there. If questions actively require context, so if you've got lots of queries that include a user's current location or a user's current time or something, that's going to be something that's going to be quite hard to fine tune for. If you have computational or other sort of logical requirements that are hard to align, so for example, I can't think of any examples now, but yeah, what I mean there is that you've got external requirements that don't fit well into fine tuning or alignment via fine tuning. If you require a sandbox, or you're trying to run like external code effectively within your LLM or call out to an LLM, then then other approaches, in fact, are probably best there. Fine tuning is better when you talk about anything to do with style. So if you're trying to mimic style, alter the style, change the style, works really, really well. If you're trying to make it speak like a 17th century sailor, or mimic the language in the Bible, or anything like that, then it works really well. Fine tuning is really great. You couldn't do that with RAG. If you're trying to minimize latency, because RAG has to reach out to several external systems, you might struggle to keep the latency of the model down. If you have massive or continuous contexts, then RAG might be a challenge there. So if you have to, stuff in a whole document rather than just a small part of it, then you might struggle to get decent answers from an LLM that has a large context, or you might not even be able to fit it in the context at all. Or if you're looking to opinions, more generative type stuff like storytelling, and sort of more creative tasks, including new functionality like function calling. That's a big one. If you take an off-the-shelf LLM and shove RAG on the front, it doesn't instantly make it able to call out to external functions. Whereas with fine tuning, you can train it to pick the right function when you need it to. And then you've got this sort of combination of fine tuning and RAG. And so firstly, if you want to eke out the final few percent of the performance of your model, then I think the general consensus is, and it's a bit hard because it's only sort of small percentage improvements, but I think that fine tuning does add a final couple percent, probably something to do with just learning the domain terminology and things like that. And then obviously if you do need domain specific language, then that can help as well. One final thing was related to performance optimization, or resource optimization, should I say. If you're wanting to try and use a smaller model because you have resource constraints, then you might need to fine tune to actually bring the performance back up to something reasonable. Obviously, take all of that with a huge pinch of salt. My opinions based upon my own research. yeah, there's lots of people talking about this, and I'm sure they have a lot of better ideas than I can come up with. But in general, that's kind of the way that I think of the problem when someone asks me that. It's not an easy question to answer, to be honest, because it really depends on your use case. I think if I was so, let me try and sort of summarize the summary. The summary, I guess, would be if you are if your use case is knowledge based, i.e., you're trying to answer questions, something like that, then RAG is probably better. If your use case is more about style, then fine tuning might be better. And then ideally, you want to try both. There you go. That's probably the best summary I can do. All right. I also found some really interesting findings. This is a final section, but I thought it was worth including because there were some quite interesting results in a lot of these papers that I wanted to highlight. So the first one we've already mentioned is that the literature online and in papers massively underrepresent the challenge of QA pair generation. There's very little about QA pair generation, in fact. The effectiveness of fine-tuning and indeed all model training rests solely on the quality of the underlying data. If you don't have a good training data set, then you can't expect to get good results. You need a diverse range of representative questions that will be asked by your users. So in Helix, for example, we've worked hard on our ability to generate decent QA pairs, and we've had some success, but I've no doubt that there remains an open challenge for easily and more and to create QA pairs more easily and better. So it'd be interesting to see some actual research by someone more qualified than me to dig into that. Another thing that I found quite interesting is that the RAG. So there were quite a few ablation studies that were missing from many of these papers, but there was one here at the bottom. I've got a link just at the bottom there if you're interested. It did do a decent ablation study, and they found that RAG performs better with less popular topics. Or to put it another way, RAG actually doesn't work very well when the question is about a very popular topic. And the idea is that the noise or their suggested explanation for this is that the noise introduced by a RAG system can negatively affect the underlying knowledge of the LLM. So, for example, if you reach out and get a couple of different answers, like what color is a famous fast food chain's sign, and one comes back yellow, the other one's like yellowish, the other one's like, I don't know, whatever. All of those different answers that are all sort of technically correct add noise to the context, which makes the LLM pick the wrong result effectively. So it actually works better when there's less knowledge inside the LLM, so more niche topics, more specific, niche topics, and I thought that was a really interesting finding. Okay, finding number 3 is that RAG plus fine tuning tends to work better on small models. So again, in this paper, they found that for larger models, much of the knowledge that they're trying to imbue into this LLM has already been learned. And so further fine-tuning or RAG, it adds little to the results and sometimes negatively affects it. Whereas for small models, which contain less information, both RAG and fine-tuning really help. So so again, it depends on whether you are using big models or small models. This is a crazy one, actually, and just to quote my notes said, "Absolutely batshit! I can't believe this works." So this is slightly out of scope, but it was so amazing that I couldn't help to include it. So this finding is that it turns out you can fine tune on time series data. So not language, not words, time series data. In this paper, the authors chopped off and removed the tokenizer and the embedding steps from the input and the output, and instead passed in a fixed context of numerical data, which they then used to predict the output time series. This was using a standard large language model into a pre-trained LLM, and they've just chopped off the input and the output and found that it turns out it's really good at predicting time series stuff. Even when I say it, I still can't quite believe it, but I don't know. They make an interesting. It all makes sense. So I don't know how to explain it. I mean, I guess maybe there's so much power, like predictive power within an LLM now, that it can predict all sorts of different domains. Yeah, crazy, absolutely crazy. And finally, the last one is that it's really important that to remember that the prompt matter. The prompt is still really important. In this paper, they performed an experiment to compare different specificities of a prompt, from really concise prompts to really complicated, like long-winded, prescriptive ones. And they found that somewhere in the middle, somewhere around providing comprehensive instructions as guidelines, but not including examples, was about the sweet spot. So when you sort of look at these numbers comparatively, you can see that the effect of getting the prompt right is actually similar to that of fine-tuning. So yeah, you could do all of the fine-tuning you want. If you still don't get the prompt right, you're going to lose all of those gains that you've made. So you still need to think about the prompt. That was just another aside. There was a lot of conflicting research about providing examples in the prompts. In fact, this could be a whole video, I think, just research into prompt, prompt engineering, including examples in the prompts. A lot of the papers kind of suggested that providing examples actually turned out to be a bad thing, but I also know that it's also recommended a lot as well. So yeah, a bit of an open question there. Okay, so final thoughts. Whistle-stop tour of RAG and fine-tuning. I hope you leave with a better appreciation of some of the nuances. In general, I'd still suggest that RAG is probably more effective at incorporating external knowledge, but there are still good arguments to use fine-tuning. So as always, it comes down to your specific use case. If you're interested in topics like these, then please sign up to our newsletter. You can find it on basically any page on the website. And you can also find out about our future events, which include lots of LLM-related talks on our events page. There's a link there at the top, window.ai. If you've got any questions about Helix or what we're doing on the product side of things, then definitely reach out to me or the Helix team. They'll be very interested in talking to you. And I think we're at time, and I'm going to just take a quick break to allow any questions to flow in. There's sometimes a little bit of a delay in the stream, so I'll just give it a couple of minutes, and then I'll start answering your questions. Okay, let me show my face again to prove I'm still here. There we go. Okay. Hello, everyone. So yes, the session is being recorded, and I will release it on my website in a few days. So sign up to the newsletter and you'll be notified when that goes live, or you can just keep checking the website. A couple of people asking that question. So yeah, thanks for that. If anyone's got any specific questions they'd like to ask privately, then I've got my email address there, phil@window.ai. Feel free to email me if you don't want to use the public chat. Okay, doesn't look like there's any more questions coming in, so I'll call it a day there. Thank you so much for joining me. My name is Phil Winder, and if you've got any more questions, then please visit winder.ai, and I hope to see you again some other time. Thanks a lot. Bye-bye.